This is Official Nerd Business.
Hello nerd boys and girls, welcome back to another video on Project Euler, solving it with Python. This video is kind of short, at least the problem is kind of simple, so at the end of this we will be discussing a little bit about Python, specifically about lists, dictionaries, tuples and some other list-like objects, and we will also be recording a second video, and in this second video we will take a look at how we can organize our code base. That will be a pure Python video, because we are now about to crack the second Euler problem, but you can imagine that as we go along we'll get a file for project Euler number 2 and Euler number 3, etc., all the way up to, well, there are, if I am not mistaken, over 620 problems at the moment. So you can imagine that you will build up a lot of files, and to leave them unorganized is a bit of a shame. And there will be components that you want to reuse between projects, between solutions. So we're going to deal with that a little bit, and that'll be in a second video, specifically about Python, not involved with the math here. So that's it for today. Let's kick off with Euler problem number 2. That is over here. It asks us about the even Fibonacci numbers. So for those unfamiliar with the Fibonacci sequence, it is a series of numbers where you take a 0 and a 1, then you add them together, you get 1. Then you take the 1 and a 1 and you get a 2. Then you continuously keep expanding the list while adding the last two numbers to each other to reach the third number, and then repeat. So 2 and 3 is 5, 3 and 5 is 8. As you can see, the series here growing. 5 and 8 is 13, 8, etc. The next term here will be 55 and 89. Now the challenge. Each new term in the Fibonacci sequence is generated by adding the previous two. The first 10 terms are: by considering the terms in the Fibonacci sequence whose value do not exceed 4 million, find the sum of the even valued terms. So while this series is smaller than, while the number that we add is smaller than 4 million, make that series, then pick out every even number, so the 2 and the 8 and the 34, add them together, and what do you get? I've already solved this one, so here's the answer. Spoiler alert. Let's look at how we can do this using Python. So please ignore the fact that I've posted some code above. And there's this function here. Well, all we're interested in really is this little bit. This one too. This is a pure bit of Python. This will be discussed in our second video. Link in the description. Right now, when I kick off this script, it will see this bit. It will notice that it is running as a main script. Then it will jump into this if. It will see that we call run with an argument of 4 million, and run in turn kicks off this one and sums the result. So this function gives back a list of all the even valued Fibonacci numbers. So let's look at the function itself. We get an input n, which is 4 million in this case. We start off a list with the base Fibonacci numbers, a 0 and a 1. In the example they started with 1, 2, but it's really doesn't make any difference. Now you can access elements in a list by using the list name and square brackets. You can also access the last element in a list by using a -1, a -1. Well, in your list, let's have a list, for example, a 1, a 1, then a 2, then a 3, then a 5, then an 8. If I call -1 on this list, I will get this element. This is element 0, this is element -1, -2, -3. Python does this for us automatically, so that's nice. While the last element is smaller than whatever boundary we give in, append to this list the sum of the last term and the term before it. So this basically does Fibonacci now until we're at 4 million. Then we return a list, and this is a list comprehension. So whenever you see a piece of code between square brackets, that's a list comprehension. So this is this uses basically a list for input, and we manipulate it in some way, and it returns another list object. So we say here we want to take every I, so every element in the Fibonacci sequence, we will take them one by one and we will call them I, and they are in this list if and only if they give no remainder when divided by 2. So this means when they're even. Every even number that we generate in this Fibonacci list will be put into this list. This list is returned up to here, and here it is summed up for us and then passed back on to the main function, which prints it. So if we run this file, we get this number, and let's just compare this number to the answer that I already had at Project Euler. Yes. Alright, the answer seems to be correct. So as said before, this problem might seem very simple, but keep in mind that this challenge was posted to the Project Euler board back in 2001. That's a long time ago. Programming languages weren't quite as powerful as they are today. Some of the languages you see today were around back then, a lot in fact, but they were still lacking in some punching power, mostly because the 32 or 46-bit thing. We are now in the 46-bit era. That gives us a lot more in the 64, bit era. That gives us a lot more processing power, and this was something that the programming languages back then could have a problem with. So programs that we make now that solve these things trivially might not have been as trivial back in the day. So that's our Euler problem for today. Let's take a little closer look at lists and how they behave, and dictionaries, tuples, sets and ranges. I've created a little file here that just demonstrates some small parts of it. So let's kick off lists. You can make a list by simply placing two square empty brackets, and you can add elements to a list by using append. You can, to the very same list, you can append both integers or floats. I could make this something like this, or strings. This all goes into the same list without any problem. You can also add lists to lists. However, as we will see in a second, this might not do what you expect. Let's just run this real quick, and you can see here in the results, appending A, B and C added an actual list as element of our list. And if we wanted the items A, B and C added to our list, you can still use this list here, but then you need the function extend. So here is A, B and C added to our list as elements of their own instead of as a sort of sublist. Note that the sublisting feature is very powerful. So that's it for lists. Of course, you can access list items by putting in a number. There are list slices, which I don't want to get into at the moment. We will see those on other Euler problems. Dictionaries might take some getting used to. I thought it would be handy to have an example showing an actual dictionary. So you have a whatever you want to look up, a word you want to know the meaning of, combined with the actual meaning. So here we have dictionaries are defined by curly brackets, and then you can just this adds an element to the dictionary. You can just when assigning things to a dictionary, you can just put the key here, put the index here on which it has to look, and the value here, and it will automatically create it. So at the end of this, we will have a very small dictionary with 3 elements in it. And it looks like this: element and whatever value we want to store for that element, element plus storage, element plus storage. Of course, there are things that might have several meanings, several definitions. So here we have a dictionary entry that is a list instead of just a simple string. And we might have made a mistake with the orca here. It is not actually a fish, it's mammal. So let's see what happens when we print this to screen. Here we are. Orca is a big sea-dwelling mammal, and Python now holds a list with the values for snake and for programming language. Note that here is this is our printing function. Print puts everything on a new line, and we are now printing K, which stands for key in this example. D is our dictionary, and when you ask, when we would do this on a list, you would simply get the list items. But this is not a list. Every entry in the dictionary is built up of a key and a value pair, so key and a value pair, in this case a list, key and value. And when you ask something from a dictionary, you will get the keys. So here we print keys, and then we print whatever is in the dictionary for that key, so the value we look up here. So that's key and D key in our from our example in our output. On to tuples. And tuples are a sort of list, however you cannot manipulate a tuple once it is created. So here we build a tuple of 10, 20 and 30, and we can put it on screen. However, I cannot manipulate the tuple now. That might not seem like a very handy feature, but tuples as a lookup value are very fast. So this, whenever you can create a variable and know that it will no longer change, or whatever lifetime you give it, it will not change, and you just need to look it back up, then a tuple might be better than a list for speed reasons. Python can work way faster with tuples than it can with lists, because it has a lot more overhead for lists, because you can manipulate them, and tuples are fixed in that sense. We will definitely see those again. 2. Sets. Sets are also a sub-sort of list. Sets cannot hold duplicates, and sets need to be of what Python calls a hashable type, so that cannot be a list or an object or anything. Strings and numbers in different notations can be entered, and those are hashable, but not lists. So sets cannot hold duplicates, and that's also a pretty nice feature whenever you need to eradicate duplicates, and we will definitely see sets too. If we would print this example, you will see that I have a list here with 2 1s, a 3 and a 5, and it will remove one of the 1s from it. And when you convert this to a set, if you run this, we can see that one of the 1s was eliminated. And then ranges. We've seen ranges already. These are quite the interesting construction in Python, where you can give a lower bound which is inclusive and an upper bound which is exclusive, and you just assign it. Now the funny thing is, when we print R, it might not actually do what you think. It just returns its type. It specifies that this is range running from 10 up to, but not including 20. And a range only when you put it in a for loop, for example, it will simply return one item at a time. It will enumerate over its members, and it will keep track of its state by itself. But as long as you do not explicitly convert it to a list, it will just be an object. And as soon as you give the order to make it a list, so in this second statement here we explicitly call this list operator on it. So this will convert whatever we give it to a list. Excuse me, did not mean to drag. So if you put the range object in here, it will be converted into a list, and then the list is printed here. So you see here every number in the output. So that's the difference between ranges and lists. Ranges are objects that enumerate when you call them, whereas a list is already fully blown out. So that's the Python list concepts that I wanted to show you for now. I hope you found this educational, and stick with us for the second video where we will discuss how we can organize our code a little bit better. Also, I've placed this code, this file, and the extra code that we will be discussing in the second video. I've placed them all on GitHub, and I will place a link in the description. Thanks for watching this video on Official Nerd Business. Don't forget to like and subscribe and click the bell icon. Did we discuss everything you wanted to hear, or did we miss anything? Any topics you want to hear in O&B? Leave your thoughts in the comments. See you next time.